Hello everyone. This is, I think, the 11th lecture on Dart and Flutter programming. We've been discussing advanced Dart programming, and I think after this we'll start the real Flutter and Dart programming, which is we'll start Flutter framework with Dart programming language, which will be more fun than we've been doing. We've discussed last time, maybe in the last two lectures and last 3-4 lectures, about what are classes, the blueprints of objects, and then we talked about what are abstract classes, inheritance, and then interfaces, overriding, mixins, polymorphism, and most of the reason why we use these things is collaboration, that is working together, code collaboration. We should add actually collaboration here, and then maybe, yeah, let's see, so we can add collaboration here. So if we have multiple classes, people can work in multiple classes, so it will avoid redundancy. That means it will improve reuse, and readability and code consistency can also be improved by using these concepts. So the next thing that we are going to discuss of Dart, or the next concept or law or grammar, you can say it in different forms, okay? In Dart programming is exception handling. So exception has some similarity to error. We've been discussing exceptions and we've been discussing errors here and there, but today maybe we'll see a little bit in detail. So what is error? Error is very dangerous, and when error occurs in your program, actually your program halts, or it stops working and aborts, quits, and go maybe I will prompt you some message or not, but it will stop. But with exception, there might be some ups and downs, but the program might continue to work. Okay, so what are errors? Errors are some conditions or some statements in a program that prohibits your program from working properly, right? And the program may stop abruptly, or it execute with error. That means it will not give you the correct input, or the correct output, or the correct result. But exceptions are errors that are anticipated and that can be caught. Some errors that people would make by mistake, we can assume that based on the program we developed, what kind of mistake the user of this program can make. And they are not too dangerous, but they are good for correct output, or for forcing user to give the correct input. So if exception doesn't occur, then the program can continue to the next process. It doesn't stop at that. So for instance, when you divide by 0, or when you divide something by 0, it is impossible, but you can catch this exception, or the program can work if the divisible is not 0. So that's what we mean by that. So suppose you are developing a calculator and it handles division. So as long as the denominator is not 0, the calculator should work. So if x is divided by y, as long as y is not 0, the program should work properly. However, when y is say 0, the program should halt or should throw exception. So let's say you have a table, and then you have the x value and the y value, and you are doing x over y. Okay, so this is maybe x over y. So you can have 1, 3, 5, 7. You can have 2, 4, 6, and then 0. So your program should work for this one. It should work for this one. 0.75, something like that. It should work for this one too. So probably 50 over 6, 0.8, something like that. But there should be some problem here. So the program should work up to here, and it should catch the exception here. And dividing by 0 is an impossible task, so it will disrupt the program flow. But users may try, because users' behavior is uncontrollable, and handle this issue by throwing some kind of exception. This is, for instance, integer division by 0 exception. So I cannot handle such kind of division. And there are many exceptions. Exceptions are things that the program cannot work with. So when some library fails, you can have deferred load exception. When wrong format of a string is input, format exception. When you input, like when you write on a file or display on a screen, or when you read an input from file, or read an input from a keyboard, you may face some issues. So these kind of issues are called input-output exceptions. So there are some keywords in order to implement the concept of handling, or in order to implement or write the laws of exception handling. The most famous ones are try, catch, on, and finally. In this, there are, I think, a couple more, but these are the most common ones used by most programming languages. So we have the try keyword, the catch keyword, the on keyword, and the finally keyword. So you can use the try keyword with on, and you can use the try keyword with catch, and you can use the try catch finally or try on finally. Okay. When the exception is usually, like, when do you use this try on, try catch? So when the exception is certainly known, that means you know how. Maybe you'll ask now, how do I know that this is an exception, right? But when you become a very experienced programmer, you will know what type of exceptions to throw among the many exceptions. So it only comes through experience and practice. So when the exception is known, you can throw like a user-friendly message. For instance, try, what are we saying actually? Try these two codes. So at this point, try these two codes, and if these two codes have some issues, then print this. That is what we are saying. So it will come here, and then it will try to execute this statement. The result is 1 divided by 0, but this is impossible to do, right? So at this point, this is an exception. When you try this, you throw this exception. So it will say that on integer division 1, so like you can give to the user dividing by 0 or division by 0 is not allowed. So if you run this program on JDoodle or any IDE, you'll get this kind of output. Division by 0 is not allowed. Suppose you are a beginner programmer, and when you are a beginner programmer, then you may write as follows: try these two codes, if not working, then print this. In this case, it will try to divide this, and your SDK or your compiler will know that this is some not divisible by 0 or dividing by 0 exception. So you'll try this, and you'll tell your compiler to catch any exception. This is any exception, and you print this exception. Okay, so at this point the output will look like this. So it will say integer division by 0 exception. So now this is a message from the compiler or by the compiler. However, this is not understandable like when you develop a program for non-technical users or general users. Then if you display this, they will say, what is this? They'll be confused. So usually programmers know this kind of exceptions. So instead of just displaying the raw exception, we try to give some user-friendly message. The next or the other keyword that we can use is try catch finally. In try catch finally, you may want to use finally, especially when there has to be something done. Okay, there must be something that should be completed. So for instance, when you are dealing with databases and files, the databases and the files that you open must be closed. Okay, otherwise you may face some data corruption. Okay, or sometimes you may want to display thank you message, or you want to give some warning or save message. Like for instance, after you write your Word program, if you want to close it without saving, you may end up some information, or you may gain some information, or some dialog box saying that do you want to save it, or you have not saved this file, something like that, right? So there are some statements that should be executed whether this is true or not. Okay, so whether this statement is true or not, whether these two statements are executed or not, this must be executed. So in this case, probably what do you do is you display, or you just give, you actually execute the statements that must be completed. So you can see that, okay, let's divide 1 by 0. If it is impossible, just tell the user what happens, and then what? And then thank the user for using this program. So division by 0 is not allowed. This is for the user. This is for you, for the programmer, so that you can know which exception it is, or if there is different exceptions. And then the thank you program is, or the thank you message is also for user. Let's go ahead and probably write this program and see how it works. Like I've said maybe earlier, when there are small programs, it's best to write them in order to practice and become familiar. So we may start with our void main, and then we write our program. We try catch, and then finally so best to write your grammar actually like this before you write any code, because it would make it more easier to open and close your braces, so it will reduce the amount of your issue, no, the amount of your what you say, the amount of error that you do in programming. So let's say int x equals to 0, and then maybe I can say tab int result is equals to 1 by 0, and then I want to print result is dollar result. Actually this should be x, and then you catch the exception, and then you print this exception, and probably you say print thank you for using this program, right? So if I run this program, I may see some result like this. Okay, as you can see, the problem is integer division by 0 exception, and I can say thank you for using this program. I could actually try catch, I can put maybe this thing, I can just control C it, and I can just try catch on actually try on control V, and then I print because x was 0, and then I can run this program and see if it gives me this problem. Yeah, because x was 0, right? Because x was 0. But if I change actually the value of x here, maybe 2, I will not be seeing this because x was 0, but I will see this anyway. So this one says thank you for using this program, whether this is executed or not. So if I execute it, it will say, yeah, the result is 0, but thank you for using this program. This is because integer division by integer only always returns integer. Okay, so maybe if I change the number, this one by 4, then it will probably return 2. So the result is 2. Thank you for using this program. So as long as x is not 0, you'll find the true result, and whether the program ended well or whether there is exception, then you will probably get the thank you message. So this is it. I mean, not this is it actually, by the way. This is how you use try catch and exceptions. Try catch on, try catch finally, and other exceptions to make your program more efficient. This is actually called defensive programming. Okay, so what happens if there is no exception that is designed to handle some situation? Okay, we said there is IO exception, there is a division by 0 exception, there is some string format exception. So most exceptions are included in Dart. But what if there is no exception at all? When there is no exception at all, you can create your own custom exception. Okay, and with your custom exception, you can use the assert value. Okay, so for instance, the custom exception implements the exception class. So if you remember about implementing or about inheriting a class, an interface, we can discuss this. So you can see that in this line, unless necessary, it is not recommended to create exception. Since most of the exceptions that are common are written by Dart, it is not important for you to create. But suppose you want one. If you want one, you can create your own one. So in this case, what does our program want, or what type of exception we want? We want exception that will tell us some person is too old for a service. Okay, so we have a string, an instance variable name, and too old for service exception. This is the name of our class. So you can see that the exceptions we already used, the integer division by 0, these exceptions are created as classes, okay, by other programs. So we can create, so we can say class told for service exception, it implements exception. So when you create exception, always you implement the exception class. And then what do we want? We will return, or we want to get the name of the person causing exception, and then we'll print this person is too old for military service. So we have our function named toString. As you can see, we are overriding the toString function in the exception class. Okay, the exception class has a toString function, and we are overriding it. So we have our constructor. Our constructor just initialize our instance variable, and this is the exception. So every exception actually should have some toString, how to say, a toString function that will tell us what is happening. Okay, so we can come and write our method to test our class. But before that, let's discuss a little bit about assert. Okay, so what is an assert? An assert is some kind of statement that guarantees a certain condition is checked, okay, or a certain condition is always true. When that condition is false, it will force the program to not execute that statement or certain statement. So something is expected to be always true. For instance, age of a person who wants us to give service should always be less than 50. So this is a form of defensive programming to make sure errors do not occur, but it is not a good way of writing a program. And it is impossible to anticipate all the errors that will occur in your program. If you want to anticipate all the errors that will occur in your program, you will never be able to finish writing a certain program. So sometimes you can just leave it be. Okay, so for instance, if you heard the news, you may say that, oh, hackers find some exploit in Windows operating system, Mac OS or Android OS, because users or because developers cannot anticipate all the errors. We can be able to hack the system, or we can be sometimes when we are using an app, it crashes. So this is the reason, because we cannot anticipate it, and if we want to make it bulletproof, it is impossible. So, and the other thing here that you should know about assert is this method we by the Dart is still under development and it has some bugs. So you use this very carefully, and most of the time you have to replace, like if you don't want to use assert, you can replace it with an if-else statement. So let's take a look at our example that makes use of this assert statement and the try-catch statement on our own exception. Okay, so we create our main program, and then we create a map of a person and its age. So if you remember, when we talk about variable types, we talked about maps and lists and sets. So we created a map because in a map we can create our own key and then the value associated with it. So our map is containing a string key and an integer value, and then we call our map in listed, and then Tom is 21, Dick is 37, Harry 51, and Mark is 52. And then we create another map to store the qualified people, or the people that are qualified. So we probably go through each user. We go through Tom, Dick, Harry, and then find out whether they are qualified or not. So we say that enlisted that for each. So we call for each element, okay, for each method. So enlisted that for each method. This method takes out each element of the map. Okay, so what does this do? Enlisted that for each, it will take Tom into name, age into 21. It will put 21 onto age and Tom onto name, and then it will check whether the age is less than 50. If the age is less than 50, then on our new qualified map we add this element with the key of the name and the value of the age, and then we go the next, okay, for each. Since it's for each, so we put Dick onto name, 37 onto age, and then we do this again and again and again. So when you finish checking all these elements or all these people or persons to check whether they qualify for military service, then you print we finished, and maybe enlisted.language means like there will be four of the two of the people, like four of the two people, the two candidates are valid, and then we print out the list of qualified. Okay, so it is like one thing here. So if the age is greater than 50, actually we throw the too old for service exception with the name. So what happens here? It will go to the too old for service exception, and then whatever is in the toString will be stored here. Okay, so whatever is here, whatever is in toString, it will be stored. This element or this statement will be stored in E. Okay, and then E will be printed. So for instance, we'll start for Harry and Mark, age is greater than 50. So when we reach Harry, age is greater than 15, so we just call or we just invoke too old for service exception with the name of Harris, and it will say that Harry is too old for military service, and then Mark is too old for military service, and then it will print finish, and then it will say four of the two candidates are no, not actually four of the two candidates. This must be two of the four candidates are valid, and then the list of the qualified are Tom 21 and Dick 37. Okay, but if you run this program on let's see, if you run this program on JDoodle, since this assert statement or assert method is still under progress. You may end up looking at 4 out of 4 candidates are valid. If I run it in my IntelliJ IDE, actually I can get a similar result to this, but with JDoodle I cannot. So maybe what I can do is I can replace this with an if-else statement. So if I replace my previous assert statement with an if-else, like if age is less than 50, then I will add that age. I will add that person to the qualified map. Otherwise, I'll just throw a new exception of too old for service. And you can see that by replacing assert with an if-else, I can have the same result. Okay, so you can see that Harry is too old for military and Mark is too old for military service. And 2 out of, so I modified qualified.lengths and enlisted.lengths. So 2 out of 4 candidates are valid, and the list of qualified are Tom and Dick. So what you can see here is that replacing by assert by if-else is good, but if assert was without a bug, then it would be very simple code to write. You can see that if assert was working properly in JDoodle and everywhere, it would have been very easy to write this statement instead of an if-else, right? So that's why, like, having too much if-else in a program is also not a good practice of writing. So we invent such kind of trick to avoid it, but for the time being it's not working properly, so we can skip it. So you can create your own exception. You can create you can use an already available exception. Another advanced concept that we'll see in this chapter is asynchronicity. That means to do multiple things at the same time. Sometimes when you are in a class, while you are listening to what the professor is saying, you also write, right? Or you can just listen and then write. So doing things asynchronously will save some time and some processing resource. Okay, so mobile and web apps or the programs that we run with Dart, actually sometimes they need to read data from server or they need to wait for user input. So at this point, users application can complete other tasks in the meantime. So take a look at these two graphs where we have 4 tasks with different completion time, and then in synchronous or in sequential programming, the first task will be completed, then the second, then the third, and then the fourth. That means you can see that it will take up to 45 seconds to complete this task. However, if these tasks are not related to one another, that means if these tasks can be accomplished separately, then you can schedule them all together, and you can see that while this task is completed, while this task is executing, the other tasks can also be simultaneously executed, and it will take about only 20 minutes. So you saved or you made your program very faster. The way to do asynchronicity is 2 ways. The first way is to use the future API, which requires Dart async libraries, or you can use the async wait or asynchronize this and wait for the result. However, this async wait also uses the future API indirectly, and this async wait also uses the keywords async wait and then. So this is maybe if we were using IDE, this is how we create our program and try to run. But for instance, let's have a program to see our asynchronous programming. Let's assume that we have a function that counts up to 100 or up to 1000 or up to any number, and then it stores this count onto some buffer. Okay, so for instance, we have a count up method which starts counting up, and then we have a new string buffer which is called SB, and our count up method returns a string. As you can see here, we are familiar with this return method, with this return type. And then what does it do? For I starts from 0 up to some count, it will store this I into a buffer, and when it's finished storing this I into a buffer, it will say finish count up, and then it will convert this buffer or this string buffer just to string, and then it will return it. But because this will take some time, we can do other tasks while this program is being executed. So we can create count up asynchronously. That means this will create our asynchronous method, and then run this method separately while the program continues. So naturally, the main program actually waits for count up asynchronously to finish. However, at this point, it continues because the task is handled asynchronously. So what are we actually doing? So let's start the program from main. Okay. So from main, what are we going to do? Like we say that, okay, main, we start our main, and then we call this function, count up asynchronously function. When we call this function, it will come here, and this method knows that, oh, okay, I am a method that is going to be executed asynchronously. And then even if this is async, this part of it is going to say to be executed sequentially. So it will say that until it meets wait. Okay, so what should I wait for? This is what should I wait for. So I am asynchronized. I will print this. This method count up asynchronously prints this, and then I create a string called value. This value is to receive this string. Okay, so wait for future class. So wait for future class, and what should we do in the future? In the future, we receive or we get what count up returns, and then we give this result to this value. Okay, so we wait for future, and then it will finish here. So if you read this program, this is a little bit advanced programming. Okay, it is even more advanced than the advanced topics we talked. So usually we don't discuss such things in programming language in the class because it is too advanced. But at this point, I'm expecting for you to be familiar with Java, Python, C++. So you've already known the programming language, other programming language. So that's why we can talk about this concept. So what happens here? It will say that start main, and then you can see that it will come to async operation started. Okay, so up to here it is sequential. Okay, start main, and up to here it is sequential. But when it reaches a wait, it becomes asynchronous. So this, everything after this has to be waited. So other programs can continue. Oh, I'm not gonna finish my program, so other programs, please go ahead and finish. This at this wait, this program is saying to other programs, please go ahead and finish because I have to do something before then. So it will start and then okay, it will come back to main, and then main prints finish main. So this is executed, but after that, like after main is executed, maybe count up is started and count up is finished, and then you can see that after count up finishes its program, or after count up method finishes its statements, then we continue here. We print async operation succeeded, and then we print this value, or the value that is returned from count up and stored in this value variable. So you can see that async operation succeeded, and this is the count up, or this is the integer, no, this is the string that is returned from count up method. So this is our program, which was already discussed. You can see that it is working accordingly, but yeah, so it will not print just in 4 rows. It will continue to print from 0 to 99. So we'll start main, go into async operation, and then finish main because async operation is started, and then finishing other async methods and statements, and then finally when the async operation is succeed or finished, it will give the result of the async operation, or the result of the async statements or program. So using all the programming that we have studied so far, you may be given some group assignment, but before I give you group assignment, I should put you in a group. This is what is difficult about teaching online. I don't know how to put you into groups. I could do it, but it is going to be very inconvenient, and I don't know how to really put you in there. But and also we might have to have some Zoom meeting in order to be able to discuss this group issues, but I don't know, I really don't know how to handle this right now. But anyways, for your group assignment, you can think of this assignment. So we are going to practice inheritance, and then there might be some issues, and for those issues you are given some hints here. So you can think of or you can consider some class that can handle that can handle bank account transaction. So a bank offers a customer two types of accounts, which are the saving account. The saving account earns interest, and the interest compounds monthly and is based on the minimum monthly balance. That means for the saving account, you can increase some money on top of it every month. But for the checking account, it has no interest, and when you try to withdraw, it will charge you $1 after 3 transactions per month. So it gives you 3 free withdrawals per month, but it will charge you $1 for each transaction. So the program will manage set of bank accounts, and it should be structured so that other account types can be added without affecting main processing loop. So we'll have some menu. We can deposit, we can withdraw, we can see some monthly inquiries, and we can quit. So this will be the menu of the program. So for deposit and withdraw, you query the account number and the amount. So when somebody says I want to deposit, which account number you want to deposit and which account number, how much amount, and then it prints the balance after each transaction. For months, at the month's end comment, it accumulates interest for saving bank accounts, and then it clears transaction, and then it prints the balance of all accounts in your program. So these are some of the ideas that you can use. So the list of the classes that you can use in your assignment are the saving and the checking, and you can employ inheritance by having a bank account, because whether a person has saving account or checking account, person's name and person's bank account number is going to be the same, right? Or is going to be similar for both classes. So you organize the class into hierarchy, inheritance with hierarchy based on superclass as a bank account. So you have to determine the common responsibilities of each 3 tasks and write pseudocode for each task and find the common task so that you can implement it in the bank account. You can decide methods to be written by saving and checking bank account from the bank account super class. You declare some of the public interfaces or the methods of subclasses, and then you can identify some instance variables such as account number, such as name, or such as interest, something similar to this. And then you have to implement the constructors in the methods, and then finally you have to write a tester program to test your program, like simulator or demo program, in order to write that. So this is easy, and you can find some materials on the internet on how to accomplish this too. It is not a very big task, but since you are not assigned groups, and maybe next week we will 100% I think determine whether we are going to continue our class online or not. If we decide to continue our class online for the rest of the semester, then there are some things I should continue to teach you. So we were ordered actually to teach some light concepts until face-to-face class starts. So these are all like actually some of the light concepts I could teach on face-to-face. But if we are going to finish this semester with online class, I will have to go into heavy concepts and start discussing even more deeply. But for the time being, just don't worry about the group assignment until you are assigned in groups. Just enjoy your time and write these programs that I have given so far, and practice. Okay, practice with programming. Practice. Okay, even if you are rewriting the programs I'm writing, I've already written. Practice. That is the only way you can understand programming. Sometimes when you write the program, you will understand what the program is about and what the concept is about. Okay, so practice the programs I've written, and please do not forget the lab practice assignments I have given so far. Okay, just keep them with you, but complete them. So this is it for today's class. I will see you in another topic on lecture 12, and yeah, bye.